Alright, let's start programming our first tic-tac-toe strategy game. The left panel of the screen is to write our code, and the right panel is to see the result. Let's start by naming our first game. Let's call it Tic-tac-toe by Caesar. We need to decide what our variables will be. Keep in mind that you do not need to decide all of your variables before starting to code. You can always add them later to the code when you need them, especially if you're not an experienced programmer. Our tic-tac-toe game usually involves 2 players. Therefore, we need to have a variable to store the player's turn. The most important thing in this game is to store the values on the board, that is, the values on 9 tiles. We can't store 9 different pieces of information on one variable. Therefore, we're going to use a different data structure called an array. What else? We may need to decide the size of each tile. For example, a width and height of 100 by 100 pixels. Remember, in programming, we measure distance in pixels. We can figure out the rest of the variables as we move along. Okay, let's get started to draw our interface. For this, we use a processing.js function called draw. For more information about functions, please visit the documentation at the bottom of the screen. Now we can assign a background color to our canvas and apply a fill color to the board as we wish. When we set the background color, we can see the change become visible in the right-hand panel. Next, we're going to draw the board with the 9 tiles using the rect function. The rect function draws a rectangle using the given x and y coordinates, the width and the height. Let's imagine we have to draw 20 tiles or 50 tiles. That means we have to write the code 50 times. Now this is a time-consuming and a very difficult task. Therefore, programming languages have a mechanism to deal with repetitive tasks called loops. Loops allow us to repeat lines of code efficiently. In this game, we use for loops. Let's see how we can easily write the same code using loops. Here we have used 3 loops to draw this board, as we had 3 columns. However, this can easily be done using a nested loop. Let's see how we can do this using nested loops. We can always change the x and y coordinates of the boards as we wish. However, for simplicity, let's keep x and y coordinates at 0. Feel free to play around with the coordinates so that you can get a better understanding. Let's now add interactions to the game. We had planned this previously on our flowchart. In this game, players need to be able to click on each tile as they play. Processing.js has built-in functions to do this called mouse is pressed. Let's create this action. Once the mouse is pressed, we draw X or 0 on the tiles depending on the player. Players need to be able to click on each tile on the screen as they play. Let's create this action using code. Processing.js has built-in functions to do this, called mouse is pressed. Once the mouse is pressed, we draw X or O on the tiles depending on the player. We need to ensure that the player presses the mouse within the board boundaries. Therefore, we write this simple condition to check whether mouse X and mouse Y are inside the board. Mouse X and mouse Y are variables to represent the current coordinates of the mouse. I am doing a simple math to calculate which tile is pressed by the player. Floor is a built-in math function of Processing.js. It calculates the closest whole number of the value within the parentheses. For example, 8.22 will become 8 when floor is applied. Now, we need to figure out which player is currently playing the game. That is the player turn. And we also need to figure out whether the pressed tile is empty. If the tile is empty, we can store X or O in the array corresponding to the tile location. For example, store X in the third space of the array if the player 1 pressed the third tile. So if the current turn is player 1's, next turn should be player 2's. So we change the value of the variable player turn into 2. Now let's display these in the board. In order to display these, we need to use a function called text. Text function needs to have the text string X and Y coordinates of the bottom left corner. Now, let's try playing the game and see how it's going on. We can change the X and Y coordinates of the text to see how it works. Yep, it's working quite well, but no results yet. We don't know who wins the game. So let's figure this out. Every time when a player presses a tile and the program draws its symbol, either an X or an O, we can check whether the game is finished and who is the winner. To check if there's a winner, we can add a condition here. For example, if player 1 does not win, give the turn to the next player, that is player 2. Now we need to work out how to decide what it means to win. If you're familiar with tic-tac-toe, you should know that a player needs to have the same symbol 3 times in a row, column, or along the diagonal. To have this happen in our game, we need to build our logic. So let's have a think. Each of these tiles has a name, usually the variable name. However, since we're using an array to store these data, we need to use the name like board 0, board 1, etc. Therefore, we can have a condition and check whether first row has the same symbol. For example, value in board 0 equals to board 1 and 2. We can do this for other rows like row 2 and 3, and similarly, we can do this for columns. For example, in the first column, board 0 should be equal to board 3 and board 6. And yes, we'll be repeating this for the diagonals too. And one thing to keep in mind is that we need to check whether each tile in the grid is not empty. Otherwise, this will give us a wrong result. Let's see how this works. Oh, the text size is huge. We can reduce this by setting smaller size. Perhaps with a different font color. In addition to game win, there can be different tie games when both players are playing strategically. So we need to implement a function to do this too. It's a bit tricky now. After we check whether a player, either player 1 or 2, wins, and if not, but none of the tiles are empty, that means this is a tie game. So let's implement this. Finally, it's all done now. Now that we have implemented all the functionalities of the game, let's try to play it once. Enjoy!